a few more examples of graphing these polynomial functions by using our 6-step process. So next one we're going to look at is this x to the fourth plus 4x cubed plus 4x squared. And let's start by looking at the far left, far right behavior by looking at the degree. Okay, so the degree of this polynomial is 4, which is even. And then also, we notice that the coefficient is positive. Okay, so the leading coefficient is equal to 1, which is greater than 0. And so what that means is that the behavior is that it's going to rise to the right, and it's also going to rise to the left. Okay. All right. So next thing we're going to do is we are going to go through and try to find the zeros of the function. Or I'm sorry, yeah, we're going to find the zeros of this if we look at our process. So going back up, we want to try to find the zeros, and then we want to try to find the y-intercept of this. All right, so the zeros of the function are going to be where the function is equal to 0. So we just have 0 equals x to the fourth plus 4x cubed plus 4x squared. We can factor out an x, so 0 equals x. In fact, we can factor out an x squared, and that's going to leave us with x squared plus 4x plus 4. And then we can factor this trinomial. So we would have x squared, and we would have x plus 2, x plus 2. Okay, and just again, notice that we need two numbers that multiply to be 4 but add up to 4. They're all positive. And then finally, what we could do is we could rewrite this as x squared, x plus 2 squared. Now notice that both of these factors, the x squared and the x plus 2 squared, have a multiplicity of 2. Okay, so this has a multiplicity of 2, as does this. So the zeros are when x squared equals 0 or x plus 2 squared is equal to 0. We take the square root of both sides and we get x equals 0, x plus 2 equals 0, which implies that x would be equal to negative 2. All right, and so what that means is that at x equals negative 2, it's going to turn around at the x-axis. And similarly, it's going to again turn around at the x-axis when x is equal to 0. All right, so now we can start plotting a few of these points. Okay, that should say x-axis. Sorry, tucked it right on the screen. Okay, and so when we graph these, let's go down here, right, and let's just make ourselves a graph. And remember, we said that our intercepts occur at 0 and then at negative 2. And it's just going to turn around at those points. And we know that the long-term behavior is going to go far left, far right. Okay, so now we can also find a few more points, and we will do that in a little bit. But let's also find the y-intercept by letting x, or we're going to let x be equal to 0. Okay, and if we do so, we're this is, by the way, this is part 3. Okay, and we're going to find g at 0, which is going to be, remember, 0 to the fourth. So our polynomial function was 0 to the fourth plus 2 times 0 squared plus, or sorry, 4 times 0 squared plus, or 4 times 0 to the third, and then 4 times 0 squared, which is just 0. And so that means that the intercept is going to be at 0, 0, which we already knew. Okay, so again, it doesn't help us too much for that. Next part that we have to do is we have to go through and to be able to determine if there's any symmetry of this function. Right? Now, this function is not going to be symmetric, and let me illustrate why. If we find g at negative x, that's going to be negative x to the fourth plus 4 times negative x cubed plus 4 times negative x squared. And when we simplify this, that's going to be x to the fourth minus 4x cubed, because of the cubic, it stays negative, and then plus 4x squared. And so because it didn't stay the exact same and not all the signs changed, it is neither even nor odd. Okay, so that means there's no symmetry of this function. Right? We'll go back and we'll check the turning points in a moment, but let's go ahead and find a couple points in between. Okay, so if we go down here, the only point in between the zeros is at -1. So let's find g at -1. So g at -1 is going to be -1 to the fourth plus 4 times -1 cubed, and then plus 4 times -1 squared. All right. And so if we evaluate this, that's going to be 1 plus -4 plus 4, or just 1. And so we have this point, -1 comma 1. Of course, we could throw in a few more points into this if we wanted to. All right, but what's going to happen is we have the point -1 comma 1, which is right here. All right, and far left behavior says it's going to go up. Right, now I don't know if this is the turning point, right, but it should do something like this, and then it's going to go up. By the way, that should not go through the axis at all. It should touch. So let me try this again. Up and then up again. All right. So it's probably going to do something like that. All right. I know this point, again, is a little bit off. So let me try one more time. We have this point. So maybe something like this. I don't know. All right, exactly. All right. But this is our point, -1, 1. This is the point, -2, 0, and this is the point 0, 0. Now, of course, we look at the number of turning points, and we have 1, 2, 3. Okay, so that last part that we had was the number of turning points. Okay, so the degree equals 4, which means that at most there are 4 minus 1 equals 3 turning points. All right, and that's valid if we take a look at this. Okay, now last thing we're going to do, let's take a look at a look at what the graph says. All right, original function right here. So graphing that function, we have x to the fourth, and then we have plus 4x cubed, and then plus 4x squared. All right, and almost precisely, we have the graph, except for this behavior in between the zeros. If we really want to get an accurate graph, what we should probably do is we should probably graph like 3 or 4 points in between here to kind of see. And that's where we really need calculus to help us to find the maximum and minimum points. All right, but at least this gives us a pretty good idea as to what the graph of this function looks like. Okay, so we have one more example to look at. We'll look at that in our final video, and then we'll be done with our polynomial functions.